Now we're going to differentiate some polynomials, which are expressions like this one with different powers of x. And we're going to do 4 examples. We're starting with this one here. So if f of x is 4x plus 5x squared minus x cubed, then when we differentiate it, we can basically apply that rule that we used last time. We can apply that to each of them. So 4x, if we apply that rule, we're going to get 1 times 4, and then x to the power of 0 is just 1. So we're just going to leave it as 1 times 4, and then we got plus the 2 multiplies in front, so we've got 2 times 5x to the power of 1, because the power goes down by 1. And then we've got a minus here, and then the 3 comes down in front, and then we've got x squared, so power comes down by 1. And let's simplify this a bit. So 1 times 4 is just 4. 2 times 5 is going to be 10, and x to the power of 1 is just x minus 3x squared. Right, so that's this one done. And let's look at the next example. So the next one we're going to do is if f of x equals 2x to the power of 10 plus x plus 7. Okay, so let's apply the rule to this one as well. So the 10 comes down in front, and then we're going to multiply by 2x. The power is going to be 10 minus 1. So it's 2x to the power of 9. And x on its own, when you differentiate that, you just get 1. And you can see that because the gradient of a straight line graph is the number in front of the x value. And in this case, the gradient would just be 1 because the number in front of the x is 1. Okay, so if we multiply this out, we're going to get 10 times 2 is 20, x to the power of 9 plus 1. The reason I ignored the 7 at the end here is because that's 7. You could see it as times x to the power of 0, and then when you multiply the 0 in front, then that's going to give you 0. So x to the power of 0 is just 1. So I'm allowed to add that onto the end. But then when we multiply by the 0 in front, we just get 0, so we don't get anything from the plus 7. Or you can see it as, when we do straight line graphs, adding numbers on at the end, that just shifts the graph up and down because it tells you where the straight line crosses the y-axis. So it's not going to change the gradient, and because we're looking for the gradient function, the plus 7 is not going to have a gradient. So this is what we get for this one. And let's do question 3. We're going to start doing some fractions here. So we've got f of x is 5th x to the power of 4 plus 3/10 x cubed plus 10x plus 1. Again, we can do exactly the same thing, just that we've got fractions. So the 4 is going to come down in front, so we've got 4 times a 5th, which is just 4 over 5. And then we're going to take the power down by 1, so 4 minus 1 is 3. And then we got 3, multiply that in front here, we got 3 times 3 divided by 10, and reduce the power by 1, I get 2. And then plus 10x has the gradient plus 10. And we can probably simplify a bit. Well, the only thing we can simplify is this 3 times 3. So let's write down, so we've got 4/5 x cubed plus 9 over 10 x squared plus 10. And that's the answer. Right, the final one, we're going to do some more fractions. But there's going to be some more simplifying to do here. So if we got 2/3 x cubed minus a half x squared plus a quarter x plus 5 over 6. Alright, so we're going to differentiate this whole thing. And we get f prime of x equals, so that 3 multiplies in front, so we've got 3 times 2 over 3 x power reduced by 1, which becomes 2. And then we've got minus, this 2 multiplies in front, so we've got 2 times 1 over 2 x, just x to the power of 1. And plus a quarter x, that's just going to be plus a quarter. So let's simplify a bit. So we've got 3 times 2 over 3. That's the same as just saying 6 divided by 3, which is 2. So we've got 2x squared. And here we've got minus 2 times 1 is just 2. And 2 divided by 2 is 1. So we just got minus 1x. Or we can write that as minus x. And then plus a quarter. So you see the number at the end here in all of them, when we differentiate it, that just disappears. So the 5/6 here just disappeared, the plus 1 here just disappeared, and the plus 7 just disappeared. So when you're differentiating, if your original function has a number without any x's on it, then when you differentiate it, that just disappears.